Here's sample test 4, problem 4. If the mass of Venus is 0.82 mass of Earth and its radius is 0.95 the radius of Earth, estimate the gravitational field G sub V at the surface of Venus. How do you measure the gravitational field in general? Let's say you are on Earth and you're standing on Earth, and basically your mass is the distance of the radius of Earth away from Earth's mass, because we treat the mass of Earth as being located at its center, at the center of mass. So you would say that your weight, mg, that you feel at the surface of Earth is due to Newton's law of gravity, g times the mass of Earth times your mass over the distance between you, which is the radius of Earth squared. Well, on both sides of this, you could cancel out your mass, and you would get the g that you know and love, which is 9.8 meters per second squared, is really due to the gravitational constant, mass of Earth, divided by the radius of Earth squared. So there is a physical reason for that value g of 9.8, and it's due to the values of Earth. Well, if you went to Venus, you would say the gravitational acceleration of Venus would be equal to g times the mass of Venus over the radius of Venus squared. But if you describe Venus in terms of Earth, this would be g times, and the mass of Venus is 0.82 times the mass of Earth, and the radius of Venus is 0.95 times the radius of Earth. Square that. So we would say that this is equal to 0.82 divided by 0.95, if I can get this right, squared, times g times the mass of Earth over the radius of Earth squared. Well, all this stuff is just the g 9.8 meters per second squared that we know and love. So this is going to be equal to 0.908 times 9.8, which is 8.90 meters per second squared. So that is the gravitational acceleration on the surface of Venus, and we didn't really have to know the values of the mass of Earth and the radius of Earth because we actually did it in terms of those values. So that was a shortcut way of doing it. Part B, how much would a person weigh on Venus if that person weighed 700 newtons on Earth? Alright, so let's take a look at that. Let's see. So if your weight on Earth is mg, and that's 700 newtons, you can actually calculate your mass, which is the weight on Earth divided by g. So 700 divided by 9.8 is equal to 71.4 kilograms. And that's something that doesn't change. That's your mass anywhere you are in the universe. So if you're on Venus, your weight on Venus would be equal to your mass times the gravitational acceleration of Venus, which would be 71.4 times 8.9. And that's equal to 636 newtons. So if you traveled to Venus, you would weigh 636 newtons, approximately 10% less than what you weigh on Earth. That's kind of a neat idea. I mean, I'm going to have an infomercial at 3 a.m. in the morning, Dr. Golben's diet plan, which means on my plan you can lose 10% of your weight and you can eat whatever you want. All we have to do is travel to Venus, and then you will lose 10% of your weight. Of course, you know, you'd have to endure sulfuric acid rain that exists on Venus and 700 Kelvin temperatures, so you might melt. The pressure is 90 atmospheres, so you might be crushed into a pancake, and so as you're melting due to heat and sulfuric acid and crushing the pancake, at least you would have lost 10% of your weight, so you'll feel good about yourself. So anyway, that's the Dr. Golben diet plan. Look for my infomercial at 3 a.m. in the morning. Answer: 636 newtons and acceleration 8.90 meters per second squared.